BMO Round 2 2022 British Mathematical Olympiad problem number 2. We want to solve this problem, and after that I will leave some homework for you related to function problems like USAMO 2023 and some IMO problems. Okay, let's read. And also another BMO problem. It says find all functions f from the positive integers to the positive integers such that for all xy, it means xy in positive integers, we have 2y f of x squared plus x equal to f of x plus 1 times f of 2xy. There are around 14, 15 important ideas in functions. For example, one of them, consider small cases like, for example, x equals 0, y equals 0, x equal here, we don't have, for example, 0, so we can say, for example, plus 1, y plus 1, and so on. One idea considers special cases, for example, x equal to y, and so on. One idea, when we have a complicated term, here we have, for example, look, f of x squared plus x. Get rid of complicated term. How? For example, in SMO, Singapore Mathematical Olympiad, in IMO, we had this idea, get rid of complicated term. How? You should write this equation twice. For example, here, because we have only x, only change y. And then if you subtract, or here, because positive integer, if you divide, sometimes with subtraction, here with division, you can get rid of this complicated term. So let's see what we have. At first, we write again main equation, 2y f of, and here we have a lot of things, consider telescoping rule and so on, especially when it is from integers to integers. 2y times f of x squared plus x equal to f of x plus 1 f of 2xy. Now, next step, it is correct for any xy that are positive integers. Instead of y, we consider x equal to x, y equal to w. So it will be 2w f of x squared plus x, and w also is a positive integer, f of x plus 1 times f of 2xw. Okay, now here, because there are positive integers, we can divide. And if we divide, this complicated term will be cancelled, 2 will be cancelled, we have y over w. And here, f of x plus 1, f of x plus 1 will be cancelled. It will be f of 2xy over f of 2xw. Now, in this case, if we consider, let's cross multiply f of 2xy times w equal to f of 2xw times y. And now, if we consider w x equal to 1, if w equal to x equal to 1, because it is correct for all x, y, w that are positive integers. So wx equal to 1. So here it will be f of 2y, w equal to 1. We can ignore that, equal to y times f of xw1, f of 2. Okay? So here I consider f of 2 equal to c. If f of 2 is a constant equal to c, then here we can say y is c. So in general, we've reached a good thing. We consider it as a lemma 1. We write anything that is good as a lemma. At the end, for example, we reach 10 lemmas that may be some of them useful, for example, at the end, and you will see 7 of them useful. This strategy is useful for all problems. Because in the beginning, we don't know which things are useful, which results are useful, which not. So for all x, let me write like this, for all x in positive integers, f of 2x equal to xc, which f of 2 equal to c. Here I've changed only y with x, it's okay. Now Let's focus on our main equation here. Here, I can say f of x plus 1 instead of f of 2xy. If I use this, you should divide, for example, 2x by 2x, x times c. Divide 2xy by 2xy, then xy times c. And then you can cancel y. So we've reached that 2f of x squared plus x equal to f of x plus 1 times x. Okay, now, because we know f of even numbers equal to what? So let's consider if x equal to 2k. And let's see what can we reach. If x equal to 2k, so let's replace, it will be 2 f of 4, 2k squared will be 2k whole squared will be 4k squared plus 2k equal to f of 2k plus 1 times 2k. Now f of 4k squared, f of 2x equal to x, you divide it by 2 and times c. So here we divide it by 2, 2k squared times c. And this number, we know c is positive integer because the problem says f is from positive integers to positive integers. So here we will understand it is even. Okay, so let's calculate these. At first, let's write the things we've reached so far. 2k squared c plus 2k equal to f of 2k plus 1 times 2k. Okay. We can also, let's do something. We can also divide both sides by 2. So here I can write it as times k. Now, again, for this one, how we've used this lemma 1? Again, we use lemma 1. And it is f of 2 times this part. Let me write it is f of 2 times k squared c plus k. Now, you should multiply this by c. Look, 2x, f of 2x is xc. Here our x is k squared c plus k. Now we say, okay, k squared c plus k is x times c equal to f of 2k plus 1 times k. And now here, if we factor from k, it will be k times kc plus 1 times c equal to f of 2k plus 1 times k. And then we cancel both sides by k. We know k is positive integer. Why? Because x is positive integer, so k is also positive integer. So we've reached that f of 2k plus 1 is what? Now in next step. And here, sorry, we had xc, I forgot c here. So we have c here, c here, c here, and c here. You can cancel also this c. And we've reached f of 2k plus 1 equal to kc plus 1. So let's write it as lemma 2 f of 2k plus 1 equal to kc plus 1 and f of 2 equal to c. Okay. And by lemma 1, we had what? F of 2k equal to kc, which f of 2 equal to c. Now let's consider main equation again. Okay, again, we say it is equal to f of x plus 1 times f of 2xy by applying lemma 1 is xyc, and you can cancel y here, y here. Now, in this case, I want to apply lemma 2, so I should replace x with, for example, 2k plus 1. Okay, so suppose if x equal to 2k plus 1. Now, it will be 2f of, because I want to use f of odd numbers, lemma 2. 2f of x squared, which will be 4k squared plus 4k plus 1, plus x, which is 2k plus 1, equal to f of x plus 1, which is f of 2k plus 2, times x, which is 2k plus 1, times c. Okay, now if I apply lemma 2 here, look for reaching k. You subtract this one by 1, it will be 2k. Divide by 2, it will be k times c plus 1. Okay, or I can write this part as what? I can say it is equal to 2k squared plus 2k plus 1. Okay, f of this. 2 times this plus 1. It is our k, this part. And it is kc plus 1. So inside times c plus 1. It will be 2k squared plus 2k times c plus 1. And now, here it will be what? 2f of this part, which will be 2k squared plus 2k times c plus 1 will be plus 2, so plus 2k plus 2. Okay, 1 plus 1, 2. Equal to f of 2k plus 2 was what? Again, if we apply lemma 1, it is 2 times k plus 1. When it is 2k, it is kc. So it is k plus 1 times c times 2k plus 1 times c. Okay, now for this part, again, it is even. Now we can apply lemma 1. Inside that is 2 times what? It is 2 times k squared c plus kc plus k plus 1. And f of 2 times even number. 2 times a number means f of even numbers. F of 2k is kc. So f of 2 times this is this times c. So it will be 2 times this part. K squared c plus kc plus k plus 1 times c equal to k plus 1 times c times 2k plus 1 times c. Now, here, and one thing that I should correct here, look, f of 2k plus 1 is kc plus 1. So here, I applied this plus 1, and let's see, okay, this one over 2 times c, and f of even numbers again is k plus 1 times c, okay? Let me tell you a trick how you can check, for example, your calculation is correct during the solution. Here, always, for example, one important idea is to check, for example, f of x equal to constant works, f of x equal to x works. If you check f of x equal to x, you will see, okay, here it will be 2x squared plus x and 2y times x squared plus x. Here, x plus 1 times 2xy. You will see they are equal. It works. So, f of x equal to x means what? C should be what? Can you say C is what? F of 2k should be 2k. So, C is 2. Okay, so we know that C2 should be one answer. And here, when we reach this, if C equal to 2, I would just want to check, do we have any calculational mistake or not? So if you replace c with 2, it will be 2k squared, 2k plus k, 3k plus 1 times 2 times, here you can cancel this c, okay? So let's consider k plus 1 times 2k plus 1 times 2. Here it will be 2k squared times 2, 4k squared, 4k squared. K plus 2k, 3k times 2, 6k, and 2, 2. So you will see, okay, our calculation is correct. Now, what we should prove? We should find all values for C that are good. So here, let's see. We take all things. Look, we can consider it because it is correct for all k's that k's are positive integer. Okay, and we can say k at least 0 because x is positive integer. We can say k greater than or equal to 0. For all of them, it should be correct. So there are two approaches here. And look here, all things we've used, for example, f of 2k plus 2, it is positive integer. This part, if also k be 0, positive integer, all of them were correct. And the thing here, we've reached f of 2k plus 1. But here, because we've proved f of 2k plus 1 here for 2k, which k was positive integer, it's not hard, we can say, okay, k is positive integer, so this part is for 2k plus 1 at least 3. So k is positive integer, and also here k positive integer. So here also, because we want to use lemma 1 and lemma 2, here you can say k at least 1. Now in this part, we have two approaches. Maybe someone says, okay, let's replace k1, and then we reach 2 times c plus 1 plus 1 equal to 1 plus 1 will be 2, 2 plus 1, 3, 3c. So 2 we can cancel that, then 2c plus 2 equal to 3c. So if we subtract 2c from both sides, c is 2. Solution number 2, which is harder but in some problems is useful. Maybe solution number 1 doesn't work. You can take all things to one side and say, okay, 2k squared c plus 2kc plus 2k plus 2 minus, you take these things to left hand side, k times 2k squared c, and then k plus 2k, 3kc minus, you take it to left hand side, minus 3kc, 1 times c minus c equal to 0. Now we cancel this, and the coefficient of k will be what? 2c plus 2 minus 3c plus 2 minus c equal to 0. Now it is a polynomial. Here it will be what? K minus c plus 2 minus c. It is a polynomial with degree 1 in terms of k. So for infinitely many, let me tell you, for infinitely many k, it is 0, but we have at most one root if all coefficients are not 0. But because for k1, k2, any all terms is 0, so each coefficient should be 0. So c plus negative c plus 2, 0. Here, this coefficient 2 minus c equal to 0. From this part, c equal to 2. From this part, c equal to 2. Now, that c equal to 2, we conclude what? We conclude that here 2k plus 1 starts from 3. Here 2k starts from 2. So we can say what? We can say f of x at least 2 equal to x. Okay, because when c is 2, it is 2k plus 1, f of 2k plus 1, 2k plus 1, f of 2k equal to 2k. Now let's consider, we can say lemma 1, lemma 2, lemma 3. For x that is integer and positive integer and x is at least 2, f of x equal to x. Now the only thing that is left, how to calculate f of 1. Let's consider main equation again here. I want to see is f of 1, 1. So let's replace x with 1. So it will be what? It will be 2y f of 1 plus 1 equal to f of 2 times f of 2y. We know that by lemma 3 for all x greater than or equal to f of x equal to x. Now we know f of 1, for example, let's consider f of 1 is d, okay? And we know d is at least 1. So here, f of 2 is 2 by lemma 3. F of 2y is at least 2 is 2y, so if we multiply it will be 4y. Now, f of 1, it will be 2y f of 1 is d plus 1 equal to 4y. If we divide both sides by 2y and we know x, y are positive integers, the problem says, so f of d plus 1 equal to 2. And now, we know d is at least 1, so d plus 1 is at least 2. So you can use lemma 3. So it will be d plus 1, because f of x is x, equal to 2, so d is 1. So we proved f of 1 is also 1. Now, lemma 4, we reached for all x in positive integers, f of x equal to x. Now, one thing is left, that y, always check in main equation at the end. And only check main equation, not the results you reach, to make sure. Do not have any calculational mistake. Okay, so let's consider it is 2y. F of x squared is x squared. F of x squared plus x is equal to x squared plus x. F of x plus 1 equal to x plus 1. We want to see is it equal or it does are two sides equal or not? X plus 1 times 2xy. Now we cancel 2, we cancel y. Here it is x times x plus 1 is x squared plus x. Left hand side also x squared plus x, so this part also equal. So let me write some homeworks for you. As homework number 1, you can solve this USAMO problem. Question number 2, last problem. And that R plus positive real numbers, f from positive real numbers to positive real numbers, such that for all xy in positive real numbers, f of xy plus f of x equal to x f of y plus 2. I release the solution of this problem. You can use that also in my playlist related to your USA Mathematical Olympiad. Homework number 2 is a BMO round 1 problem number 6, I think. Okay, this is for BMO1 2019. You can also try this problem. As homework number 3, let me tell you, IMO problem. Homework number 3 is IMO 2019. So try this problem. There are also another function problem, I can say other functions problem in USAMO and IMO, especially important ideas considering, as I said, telescoping rule, special cases, check is it 1-to-1, lots of important ideas. If you want to learn them, important ideas in functions and also other topics, as I said before, feel free to send message to my WhatsApp number in the description comments. Okay, thanks for watching this video. Have a good day and bye.